Over 30 years ago, the C-130 transformed military airlift operations. During the Vietnam War, its service was crucial, fulfilling both resupply and transport roles. The C-130 saved thousands of soldiers on the ground. Although other models have been designed, none have surpassed this legend in military aviation. The C-130 Hercules remains one of the most extraordinary aircraft worldwide. Still in production after 35 years, Lockheed's Marietta, Georgia plant recently completed the 1900th C-130. Though it appears similar, every component has been updated. The Hercules that rolled off the line in the 1950s have become today's advanced models. From the start, Lockheed's leadership believed in the C-130. At the time, company head Robert Gross forecasted that the Hercules would meet current needs and continue to fly far into the future. Seeking to modernize their outdated and bulkier transports, the Air Force and Army were set to embrace the jet era. In essence, what they needed and got was a hybrid of truck, jeep, and aircraft. Mr. Bob Roach, Lockheed's vice president of the Hercules program, led the initiative.
They came up with a requirement for a tactical transport that had some very unique demands, such as a drive-on, drive-off capability on the airplane, which required the whole aft end of an airplane to open up, and numerous other unique requirements. And many people who saw the design, including the renowned Kelly Johnson, commented that it was the ugliest airplane he had ever seen.
The C-130A took its first flight on April 7, 1955, piloted by Mr. Leo Sullivan.
Well, it's been a long time since the first flight, but I got to tell you that from the day we first flew the airplane, it was probably the finest transport anyone could have. Today, in the C-130, we produce 3 aircraft a month. In days past, we've produced as high as 18 aircraft per month.
Lockheed engineers are still actively creating new versions to ensure production extends into the 21st century. Over time, the Hercules has expanded in size, range, and capabilities. The B model introduced numerous upgrades, including more robust engines. 4 Allison T56A47 engines powered this model, with the older 3-bladed propellers swapped for 4-bladed ones. The maximum range was boosted to 4,000 miles. In an effort to reduce takeoff distance, Lockheed added boundary layer control, incorporating 2 jet engines alongside the 4 turboprops on the Hercules. The jets directed air over the control surfaces, enhancing lift and enabling the aircraft to lift off after a ground roll of roughly 400 feet. The C-130E model, produced for the Military Aircraft Command, boosted the aircraft's cargo capacity to 155,000 pounds. Range was the key improvement in the C-130E, as it could cross the Atlantic non-stop. On short, rough airstrips, the Hercules often uses jet-assisted takeoff, or JATO, reducing takeoff distance from a 1,500-foot minimum to about 800 feet. The latest Hercules model, the C-130H, incorporates many upgrades, making it thoroughly modern. When the military needed an aircraft to deploy troops and supplies, the C-130 was available. Lockheed's Hercules introduced prop jet power to transport aircraft. Even the Navy, setting aside its natural rivalry with the Air Force, adopted the C-130. The Marines initiated this by seeking an assault transport that could also serve as a tanker. One of the Hercules' most striking feats was a carrier landing. The pilot earned a Distinguished Flying Cross by firmly landing the plane on deck. Despite its success, the Navy ultimately decided that carrier landings were too risky for the Hercules. Today, the Navy employs the Hercules for refueling, paradrop, and resupply operations. The U.S. Coast Guard regularly flies patrols with its H-130s, tracking and marking large Atlantic icebergs that threaten northern shipping routes. A growing responsibility for the HC-130 involves spotting and monitoring oil slicks. Once detected, floating barriers can be deployed to help contain the oil. With global demand for offshore resources, coastal surveillance has gained importance. Many countries have extended their territorial waters to 200 nautical miles. Coast surveillance teams worldwide consider the Hercules an ideal aircraft for maritime patrol. Currently, over 60 countries are using more than 40 different commercial and military Hercules versions. In any color or configuration, the Hercules has always shown up in times of need. It has delivered food to the hungry, provided relief to disaster victims, and brought hope to isolated areas worldwide. It's no wonder this flying truck is often called the Samaritan of the skies.
The C-130 is a crew airplane, and it really is a crew airplane in all the best sense of the word. Everybody is working together. Of course, at different times, people have different workloads, but the people flying the airplane flew it as a crew, and many times on the ground you stayed as a crew too.
We call it pig and hog and, other little terms you probably heard today. Especially when we're trying to make it do something like land, talking it down. It's the same thing when you're fishing. You got to talk to the fish. You won't catch it. It's just like the airplane. It's the same thing. Down there, you got to talk it down. It's part of it.
Perhaps the C-130's most heroic chapter was in Vietnam. The aircraft's full capabilities were tested under these intense conditions. The men flying the C-130s were as integral to the war as any frontline soldier. The Hercules story in Southeast Asia is also theirs.
First day of the mission, quite an interesting factor. One day you're doing one thing, actually one part of the day you're doing one thing, the next day you're doing something different. Had a lot of diversions, combat essential missions, hauling ammunition, emergency airbags, taking people out, mass casualties, and so on. Keeps you on your toes.
I had a real good diversion last time. I was flying a mission, almost through with it, and they diverted me in for emergency blood resupply into the province up north. And it was real interesting. I mean, we weren't expecting it. We thought we were through for the day. Went in there and hit the bust the ceiling. It was right down at mountains and land on a short field. It was real slippery. Scared me a bit nervous.
Touchdown markers, 200 and 500 feet down the runway with red color.
Roger, copy, We're in the airlift control center of the 834th Air Division in Saigon, where the daily flight operations of the airlift in Vietnam is monitored, scheduled, and controlled. The boards that you see in the command center are used to display all the mission information for the some 800 to 1,000 sorties that are flown each day by C-7s, C-123s, and C-130s of the 834th Air Division. The 130 will operate in 2,500 feet, so it does have the capability to go into the forward areas, into the unimproved strips, and where the activity levels are high, the C-130 has proven to be the real workhorse of the fleet.
Came under a rocket attack while we were there, so we got a delay out of there. Took off, I think, at about 7:45. Went up to Quang Tri. We had a combat essential load into Quang Tri, some tank tracks for some tanks going west to Quai Son. And we landed at Quang Tri at about 9:30 this morning. When we landed there, we had some problems with our airplane with the nose gear and some engine problems. We had to stay there for about 4 hours and work on the airplane. At about 1 o'clock, our command post sent another airplane in to pick us up. That picked us up and took us down to Chu Lai, where we had some rockets to pick up to take back into Quai Son.
that crew flew into Quezon. We landed there at about 4:30 tonight. It took off again about 5 o'clock, came down to Da Nang for fuel, and returned to Tan Son Nhut. That for us is just about 18 hours. It's 29 now. It's late.
I am a flight nurse for the 903rd Air Medical Evacuation Squadron. We have approximately 20 litters and 53 ambulatory patients. They're the best pilots in the world. They'll land on a dirt strip or they'll land on a piece of steel stuck in the middle of some godforsaken place and do a tremendous job. I think the most difficult landing I've ever been on is at Antoy, which is the western part of an island off the western part of Vietnam, Phu Quoc Island. And it has a minimum runway, no lighting. And we went in there one night, it was just pitch black, raining like cats and dogs, and they had smudge pods and jeeps lighting the runway. And those fellas stuck it down there, just beautiful.
Well, you hear pros and cons, from all the troops around. You hear saying we're doing everything over here, and the Vietnamese are not holding up their end. It's their war. They should be fighting more of it. And you get a mission like we had today, and you go up there and you pick up these troops that had saw some that had their legs blown up, some of them burning half to death. And I tell you don't get that walking around out on the street. You get kind of mixed feelings, I think. Of course, you're happy to get them out of there because they're hurt. You want to get them back where they can get some treatment, some good treatment. And it's also kind of depressing. You can't get away from that. Of course, that's part of the war. People are going to get hurt. They were fighting their war. There's no doubt about it. The first KIA I ever hauled. I don't remember the exact place I picked it up, but I knew before we landed that that's what we were picking up. I didn't know how many, and as it happened, we were empty. We had no other cargo on board. We came in, and we brought an ambulance out. It was an unmarked ambulance, and of course I knew they were GI KIAs, and it really makes you stop and think about like Alan has said before, that it may be somebody you know, or it could be you at one time or another. And it's really a bad scene as far as, especially if you've got an empty cargo compartment. There's just you and them, and it seems awful crowded at times.
The C-130 lift was a lifeline to Quezon. They said it was a victory through air power, but for us trunks on the ground, it was really a victory for the 130 capability to deliver here. We had TAC area support. These ridge lines in here, we had fighter jocks supporting. I guess B-52 strikes were running right up to the perimeter. But there were days when there was no TAC close air support, and the 130s continued air land. They'd land up in this area and they'd take fire from the hills surrounding it coming in. They'd be under fire almost constantly, and then when they landed, the NVA and the hills would start flipping a few in on them. We got the name of calling them mortar bait all the time. Their ground times then used to extend sometimes up to about 1 minute. You'd have 60 GIs run on to get out. Sometimes we keep a little longer for medevac. Then they decided the method of delivery they'd use was a container delivery system.
Just off this horizon here, we set up a drop zone of about 300 by 300 yards. Very tight, small drop zone. I used a CDS drop. About 600 feet, successfully put in about 150 to 200 tons a day. We had some equipment we couldn't deliver in containers. These 1-ton containers, heavy bunker and barrier material, some of which you see around Quezon today. We asked the Air Force what they could do. Started with a LAPE, low altitude parachute extraction. They successfully delivered for a number of days just tons and tons of barrier material and supply. They were continually taking mortar fire. So we went again into another system called the ground proximity extraction system, which is an arrested barrier and a hook. Our requirements for beans and bullets were well over 200 to 300 tons a day. We got a hell of a lot of in with choppers, but the heavy tonnage requirement was moved by the old 130s attack. It's been my experience with working with the airlifters during the last stint here, that they supported us in the Delta, back into the Ashore Valley with the first team at Al Louie. They've lost airplanes every trip, but I'll say this much for them. You call them, tell them where it has to be, and they'll put it in.
This is a job for airlift all the way. I tell you, man, those damn F4 jobs, those 100 jobs, those buff jobs, they're going to be gone. We're still going to be over here hauling trash. Who's important? Tell me. It's important.
Hercules also took on combat roles. When South Vietnam moved into Laos, the C-130 dropped 15,000-pound bombs to clear landing zones for helicopters. At night, AC-130 gunships equipped with multiple guns and cannons located and destroyed North Vietnamese targets.
Yep. 3 low. There's a hit. It's on lower. Lower. Oh, wow. Go. Nice hit you. Oh, way up on it. Okay, you got any more? That's a boat? You betcha. Negative. Track hit. Alright, tank 1 is target 4.
Thanks.
Candy's moving. Hit him right on.
Continuing this mission today, Hercules remains armed and prepared. This C-130A is the first production model delivered to the U.S. Air Force. Tall number 533129. It holds more firepower than any fighter or bomber dedicated to close air support. This Hercules, known as Spectre, is part of the 919th, the only Air Force Reserve Special Forces group based at Duke Field, Florida. It operates with a 14-person crew, including 5 gunners who manage its weapons. These include 2 7.6mm miniguns, 40mm Bofors cannons, and 20mm Vulcans. When all 6 guns are in action, they can unleash over 17,000 rounds per minute. Spectre is a C-130 designed to operate effectively in the dark. Using television, electronic sensors, and infrared systems, it detects and destroys enemy targets by night. The operations booth is where everything converges. Here, systems operators and fire control officers coordinate with the electronic warfare officer. His role is to locate and counter enemy radar threats. Working with the illuminator operator, he helps protect Spectre from enemy ground fire. He can launch infrared flares to divert enemy heat-seeking missiles.
Well, PD is going to the requirement. Got a copy of the 5 vehicles. PD is trying to the lead vehicle to city on. Happy PD primary, city primary. That's all. That's the shot.
The type of warfare in Southeast Asia required heavy use of close air support, with aircraft called in to support ground forces. The Hercules served as an airborne battlefield command post, or ABCCC. The C-130 directed joint air and ground missions, managed direct air support and airborne communications during special strikes, and acted as a command center for air rescue operations. The ABCCC included a large boxcar-sized array of communication and observation equipment. This setup was installed in the C-130 for airborne missions, or could be deployed in a forward area for ground operations. Today, the Hercules still serves as a platform for the ABCCC. The C-130 fulfilled many roles. The RC-130 variant housed a massive camera lens in its belly, with additional cameras and specialized avionics in the cargo area. The RC-130 mapped landscapes and updated maps for numerous countries. Remote piloted vehicles, or drones, were launched from the DC-130 version of the Hercules. Drones have been in use for quite some time, and during the Vietnam War, they became a viable alternative to manned flights. Drones completed over 3,000 missions in Southeast Asia, with 200 lost in combat. Losses that would have otherwise been manned aircraft. Today, drones primarily serve two functions: photo reconnaissance and electronic warfare support. On a photo mission, the DC-130 launches a drone that descends to 500 feet to photograph targets. In electronic warfare, the drone enters high-threat zones to jam enemy radar, either by dispersing chaff or deploying jamming devices. A remote control officer on the DC-130 monitors the drone's activity. When it returns, CH-3 helicopters retrieve it mid-air. Crews often joke that when trying to catch the 3,000-pound bird, it's hard to tell who's catching whom. But with the HC-130 coordinating, the rescue helicopter stays in firm control. This Hercules model manages search and recovery efforts, relaying distress signals to helicopters for land and sea rescues. The JC-130 Hercules even assisted in retrieving astronauts returning from space. Equipped with hooks and winch lines, it captured instruments descending by parachute from orbit. As a capsule descended, the JC-130 would snatch it in mid-air. Other Hercules models pioneered airborne winch systems, lifting loads into the plane, leading to new rescue techniques. The JC Hercules laid the groundwork for the MC-130 Combat Talon. Special Operations Forces use the Talon equipped with the Fulton recovery system for live pickups. The Talon can recover downed pilots, rescue agents, or retrieve classified materials from enemy zones. Thanks to terrain-following radar and all-weather capability, the MC-130 and its skilled crew can reach areas inaccessible to conventional aircraft. With the Fulton system, gear is paradropped to the person on the ground for pickup. It takes around 20 minutes to don the special recovery suit and get ready for the pickup. During this time, the Combat Talon crew completes final checks of the Fulton system. The person on the ground releases a helium-filled balloon to position the pickup line and signal that they are ready. And they're ready for the ride of their life. The unusual Hercules is Britain's Sea Mark II weather aircraft. Behind its long, candy-striped nose is an array of advanced weather equipment. While the U.S. Air Force WC-130 may not appear as distinctive, its mission is just as crucial. While the U.S. Air Force WC-130 may not appear as distinctive, its mission is just as crucial. The WC-130 is known as the Hurricane Hunter.
Where most pilots try to avoid severe weather, our pilots and our air crews go looking for the worst weather known to mankind.
I'm Lieutenant Colonel Dennis Wood, commander of the 53rd Weather Reconnaissance Squadron, or as we're better known, the Hurricane Hunters. We are one of only 2 such units in the active duty Air Force and 1 in the Air Force Reserves. Our primary mission is to fly into the eye of hurricanes in order to gather weather data for the National Hurricane Center, which they use in the forecasting of movement, strength, and development of tropical storms. The weather officers and drop zone systems operators are part of their weather service, while the remainder of the personnel are assigned to the 53rd Weather Reconnaissance Squadron.
Let's go fly storm. You fly into the weather environment to look at it, to study it, whereas in a normal assignment, you usually stay on the ground to do that.
A lot of times we'll go out and fly the same hurricane 3, 4, 5 days in a row. A lot of those times you end up flying about 12 hours. You come back and land and you have 12 hours crew rest and you're out again, the same storm the next day.
In this particular mission, a navigator is really important because a computer can be used from point to point, but we don't fly point to point in a storm. We're trying to draw a line to the center of the storm, and it isn't always straight. Every storm's different. Nothing can be decided ahead of time.
Once you go to the wall, that's probably the busiest time for us. Not too much thought about the hurricane goes on. If it's real bumpy, you just try and work the best you can. We release the sign into the atmosphere, and it free falls with a parachute, sends back pressure, temperature, and humidity. From that, we take the data, analyze it, and then send it back to the Hurricane Center.
Everything's done in a real safe manner. In over 100,000 flying hours, we've never had a major aircraft accident.
The experience that I've had that I really think is worth mentioning is the first storm, because it's beautiful to look at. It just struck me that I was very fortunate to be able to see a hurricane from that direction. Not many people have.
I think that we're doing a valuable service for the people of the United States, but the mission we do will save some lives and help people prepare. It gives us a great satisfaction to be doing that type of humanitarian mission.
There we are. How about that?
Willie Don, 320 on deck after DCA for right turn on.
The roar of jet engines and the thud of the world's largest skis helped bring Antarctica closer to the world when the Hercules made its historic landing at the South Pole. It was the first aircraft of its size to land there, revolutionizing Antarctic operations. Antarctica, the Great White Continent, spans over 5 million square miles at the Earth's southern tip. For centuries, its freezing temperatures and long polar nights kept the South Pole in glacial isolation. Bridging the vast cold and distance has been the dream of every polar explorer. In 1928, Richard E. Byrd led the first major American expedition into Antarctica. Among the expedition's equipment was Byrd's aircraft, a Ford trimotor called the Floyd Bennett, selected for its size, durability, and power. The team struggled with the plane, trying to protect it from the harsh elements. From the start, the land seemed to resist any attempts to prepare for its aerial exploration. Finally, in November 1928, the Floyd Bennett was ready for its historic flight. Months of effort culminated in the ultimate test of the aircraft's capabilities in the Antarctic. Byrd planned to fly the Floyd Bennett directly over the South Pole and photograph the journey. On November 29th, Byrd and the Floyd Bennett took off from the base camp at Little America. Those left behind tracked his progress via radio, offering cheers and wishes of good luck as he departed. Having come so far, Byrd succeeded in the skies. Freezing temperatures and icy winds couldn't deter Byrd and his plane from reaching their goal, the South Pole, 90 degrees south. Byrd dropped the U.S. flag as he flew over the exact spot, making a historic moment. His dream had come true, and his flight was a success. It marked the start of a new era for aviation in Antarctica, opening the door for more extensive exploration of the vast, inhospitable continent. In the 1930s, Byrd made other expeditions to Antarctica, though not always with the same success. Several planes were damaged or destroyed by the harsh winds and cold. In later years, skis and prop jet engines would help fulfill the dream of polar flight, opening more areas for exploration. The Hercules arrived fully equipped for the job, landing on the world's largest skis, 20 feet long and weighing 1 ton each. The LC-130 can land on a remote ice shelf with the same ease as on a dry runway. From the outset, LC-130s supported the Navy's Operation Deep Freeze, along with other scientific missions at the South Pole. They revolutionized the exploration of the Great White Continent, taking scientists to previously inaccessible locations. The Hercules became a vital lifeline, delivering food, fuel, and supplies to these remote outposts. At the other end of the world, the L-100 commercial Hercules transported 100 million pounds of supplies, food, and equipment to Alaska's oil fields. Hercules also played a crucial role in transporting construction materials for the Alaska oil pipeline. The global Hercules fleet has accumulated nearly 19 million flight hours, maintaining a strong record of safety and reliability. The C-130 Hercules, the true workhorse of the jet age. A one-airplane Air Force.
For years, the C-130 has played the part of its name, Hercules, and always in a helpful role. It is used to haul cargo, troops or passengers, and litter patients. It is an indispensable element of TAC airstrike deployment and is a launch platform for Firebee drones. It performs air rescue pickups from land or sea. And can be used as a tanker for HH-3E helicopters. It recovers capsules from Discoverer satellites, performs photo mapping missions, and tracks storms for the Weather Service. It has been used to support operations in the Antarctic and is included in the inventory of the Navy, the Coast Guard, and 13 foreign countries. Here at Wright-Patterson Air Force Base, under the management of the Deputy for Limited War, the Deputy for Flight Test changed its costume again to play a different part, the role of a night-prowling attack aircraft called Gunship 2. With its electronic eyes, it seeks for and finds its own enemy targets, then smashes them with a devastating rain of firepower from 8 side-firing Gatling-type guns at a rate of 34,000 rounds per minute. But before this AC-130 prototype could be sent to Southeast Asia, months of modification and testing were required. One of these was the stuffing of fuel tanks with inerting polyurethane foam for the suppression of explosion in the event of an incendiary hit. It was very important that each piece of foam be cut to fit snugly and exactly around pipes and tubing, and into all corners and crevices to eliminate any voids where fuel could accumulate. An aluminum booth was also built for the sensor operators and for installation in the center section of the aircraft. The booth was completely insulated with about 2 inches of Celotex, and then a layer of sound-deadening acoustic tile was also applied on the inside to reduce aircraft noise about 45 decibels to provide greater operator concentration on imagery and instruments. To provide even greater safety, its floor was armor-plated. Many items of equipment were removed from the interior of the aircraft for the addition of 4 of these 20-millimeter side-firing Gatling-type cannon on their special mounts. 2 were mounted forward and 2 aft. Mounting the cannons presented several problems. While they could be bore-sighted as to azimuth and elevation, they had to be anchored in a fixed position. These 2 at the rear posed a special problem because 2 7.62-millimeter guns were mounted immediately above them. The forward cannons were mounted just behind the pilot's compartment. This was an easier installation because the 2 miniguns were mounted above and aft of the cannons. Nevertheless, all 8 guns had to be wired into the computerized fire control system so they could be fired in any combination or rotation the pilot wanted. Some idea of the tight fit of the rear guns is shown here as engineers closely examine the clearances that have been allowed for their operation and maintenance. The installation of the forward miniguns was comparatively simple and allowed ample room for the tubes that capture the spent shell casings and for final inspection of the installation of both the guns and their wiring. The sensor operator's booth was then installed. Several censoring devices and other electronic equipment will be placed in it. The loose curtain around it is ballistic felt for further protection from flak. This is a better perspective of the forward 20s with miniguns above and aft of them, the aft 20s with miniguns directly over them, and the side-looking installation of a Beaumark A radar. This first radar installation proved unsatisfactory and was changed later. This view of the two rear 20mm cannons next to the radar shows how compact all modifications had to be. The two forward 20mm cannon have been installed at an extremely low angle of depression, but this was not their permanent position. A view forward shows the 7.62 miniguns mounted in their firing position. Here again, compactness of installation is demonstrated by the closeness of the forward miniguns over the wheel well, and the size of the apertures in the fuselage, which are just large enough. With all major modifications to the aircraft completed, a last walk-around check and inspection is made before takeoff for Eglin Air Force Base for first flight test and static test firing. For the flight to Eglin, the guns were stored inboard and the gun ports closed. At Eglin, the aircraft was made ready for its first static test firing of the 20mm cannons on their specially fabricated gun mounts. This was the first deficiency encountered in the mounting of the guns. They weigh 350 pounds and had to be manually worked into their cradles affixed to the base plate. A third man was needed on the inside to help and to set the gun at the desired elevation. After all four guns were placed, anchored, and sighted, the belts of ammunition were loaded. The aircraft normally carried 6,000 rounds of 20mm high-explosive incendiaries and fires at a rate of 2,500 rounds per minute. The first static firing showed a deficiency in the mounts that allowed the guns to whip. A close-up shows the extent of whipping that brought about a pattern of widely scattered hits. Even though all guns showed the same whipping, an airborne firing test was made to learn what the results would be. The four squares are the target on the pilot's fixed reticle. The rear guns fire, miss widely, and aircraft vibration is noticeable. Then the forward pair of 20mm cannons were fired. And this air-to-sea view shows how far off target they were. The second and third bursts were also wide. Then all 8 guns were used. The miniguns were closest, some being on target, but they generally hit in a widely scattered pattern. Correction of these conditions was a prerequisite, so the aircraft was flown back to Wright-Patterson for further modification and the addition of other items to make it ready as a night prowling aircraft for combat duty in Southeast Asia. The change began with the addition of camouflage in the colors used in jungle country. Apertures were cut out for the addition of several censoring devices. The tedious and intricate job of wiring all guns, communications, and electronic equipment was accomplished. The forward-looking radar on the nose was checked and inspected to ensure its accurate and efficient operation. Heavy armor plate was cut to size for addition to the aircraft's flooring sections to take and absorb direct hits from small arms ground fire and heavy flak particles. The Beaumark A radar was further modified to work with ground beacons. This makes possible firing at targets offset from ground beacons, thereby bringing all-weather support to friends on the ground. A new direct view night observation device called NOD was also installed. In effect, NOD is a nighttime telescope. With only the stars as a light source, its image intensifier tube behind the lens will magnify the available light by a factor of 1 million, thereby making targets clearly visible. Another of the gunship's electronic eyes that was installed is this side-looking infrared system. The mirrors in the scanner head spin at about 7,900 RPMs and are part of the system that detects minute differences in temperature, as little as 1/2 degree centigrade, and turns these temperature differences into visible pictures, even in total darkness. An onboard illuminator is another important element used to search for and find targets at night. Its 20-kilowatt xenon lamp produces 700,000 lumens and can illuminate targets a mile away, and its infrared filter can be used covertly for illumination when it is too dark for Nod to see. The illuminator is used on the aft end of the aircraft, about 4 feet beyond the ramp. It can be pointed fore and aft of the aircraft, and also from side to side. After serving its purpose outboard, it can be swung inboard on its swivel joint and stored out of the way for future use when needed. The aircraft was also equipped with a newly designed UHF radio beacon system that allows the pilot of the aircraft to read direction and slant range to a ground-operated transceiver. And so the venerable C-130, which has been worked over, facelifted, officially designated as an AC-130 and Gunship II, has Vulcan Special painted on its side, and is affectionately called Big Spooky, takes off once more for Eglin and in-flight testing. At Eglin, it is taxied into position for static test firing before airborne testing of guns and electronics. All guns have been set, loaded, and made ready for the first test of the stiffened gun mounts and beefed-up base plates. The pilot checks to be sure everything is clear, then fires. First the rear, then the front. The gun whip problem has been solved, and the guns hold steady. Then all guns go. There is still no whipping, and the pattern is effectively clustered. The guns were then aimed at nearby targets, and another burst was fired. Both targets were destroyed. Big Spooky was now ready for in-flight testing. First flight testing at Eglin was done by VFR to test each piece of sensor equipment and its input to the computerized fire control system, and also to test the synchronization of the guns with the same system and sensor equipment. Now let's watch each operator using his sensor. The Nod operator scans for the target, finds it, and makes the information known so it can be fed to the fire control computer. The computer operator sets in the flight wind correction necessary for firing accuracy, and the infrared operator scans with his sensor until he too is bearing on the target. A stick control is used to direct the infrared scanner head in a search for the target. When it is found, the information automatically goes to the computer. The fire control computer gives the pilot guidance, and he flies his aircraft and maneuvers it until the needles are centered. When they are centered, he knows he's a beam of the target. The pilot then rolls the aircraft into a 30-degree bank, orders the guns he wants from the master gunner, then transfers his attention to the fixed reticle. He maneuvers to superimpose the computer-generated moving reticle over the fixed reticle to pinpoint the target. When pinpointed, he presses a button on the control column, and the guns he has ordered shoot. The cannons, the sensors, the computerized fire control, and the pilot's side window gun sight all prove out, as the target is smothered, even though it is a mile away. Then the miniguns go, followed by the 20-millimeter cannons. The orange bursts are direct incendiary hits on a target only 24 feet square. Other night mission equipment was also tested, including these Mark 24 flares in an LAU-74A launcher. The flares fall to preset altitudes, then pop open, producing about 30 million candle power of illumination as they float slowly down. In the event of a hit on the quick jettison launcher, the smoke clearing capability of the aircraft was tested with a smoke pot on the ramp. Smoke clearing was rapid and complete. The pilot calls for the xenon lamp to illuminate the target for night test firing. The black cone in the center is on target. All 8 guns were used, and all were on target. The guns, the sensors, and the computerized fire control all proved to be satisfactory for combat. With the result, the prototype AC-130 was deployed to Southeast Asia on 15 September. where it flew more than 70 combat missions in Vietnam and Laos. In December, it was brought back for rework and then redeployed to Vietnam in February. Primarily, its missions were night attacks, and the same procedures used successfully at Eglin Air Force Base were employed. Normally, Big Spooky carried 6,000 rounds of 20mm and 32,000 rounds of 7.62 ammunition. Over the Ho Chi Minh Trail, it was shooting nearly 8 tons of ammunition per night. In just 1 week of night interdiction missions in Laos, Big Spooky proved the devastating effect of its accurate and smothering firepower. On 7 sorties along the Ho Chi Minh Trail, the enemy's main avenue of supply and communications, it destroyed 23 trucks, damaged 8 more, set off 22 secondary fires and explosions, and knocked out 3 automatic weapons positions. The AC-130 has clearly demonstrated under combat conditions that a new dimension has been reached in night attack operational capability, and its impact is sure to be felt in future Air Force systems and tactics.
The Ho Chi Minh Trail, the enemy's lifeline to the war in South Vietnam and Cambodia, is an intricate and complex road system. Thousands of trucks racing and plunging along this maze of trails carry the materials of war. Materials of war that enable the Viet Cong and North Vietnamese to terrorize and attack our allies and our own ground forces. Believe it, the trucks are there, but they're not easy to find. An enemy truck convoy can always divert from one road system to another, hide under the tiered canopies of tropical forests, park and refuel under camouflage, and because of our daytime tactical airstrikes, they always run under the cover of night. The only way to stop this flow of war supplies is to search out the trucks in the night, acquire them as targets, and destroy them with powerful and accurate gunfire. For this mission, the Aeronautical Systems Division has developed for tactical employment a remarkably successful weapon system for the Air Force, the AC-130 side-firing aircraft. Flying a small percentage of the interdiction sorties over the trails, the aircraft in this program have accounted for an impressive number of all enemy trucks destroyed or damaged. Night armed reconnaissance is the primary mission of these aircraft, but they're highly versatile. They're also effective in other night combat operations, such as interdiction strikes deep in enemy territory, close air support of troops, escort of ground convoys of friendly trains, trucks, and river ships. And because of their ability to locate and orbit a target and to see in the dark, they're frequently used as forward air controllers for fighter strikes. However sophisticated the weapon system is, it is only as effective as the combat crew who flies it. 14 of you acting as one. The great majority of your missions will be flown in darkness, and every one of you in the crew contributes to the accuracy of every shot as well as to the safety of every mission. Now, the whole trick in being a successful AC-130 combat team is to understand the basic geometry of the firing orbit, develop your skills in operating the sophisticated sensors, fire control system, and weapons, and to coordinate with one another in split-second timing. For all side-firing aircraft, AC-47s, the AC-119s, or the AC-130s, the basic firing geometry is the same. The aircraft flies a left-turn orbit in a 30-degree bank at a constant altitude with the specified true airspeed around an aim point. Now, this geometry establishes a definite slant range to the aim point that's superimposed over the target. For each different attack altitude, your guns are readjusted and fixed so that your fire will hit the aim point. For each attack altitude, a different sight line. Therefore, a different gun depression angle.
Now, a sight line is a straight line, but of course, the ballistic path is not. There's a ballistic drop here that must be compensated for in the gun settings. Now, these settings are obtained by bore sighting on the ground. But when you're airborne, each gun must be fired to check the accuracy of these settings. It is this sight and gun angle adjustment that enables the aircraft to fly its 30-degree angle of bank for all attack altitudes. Notice that regardless of the attack altitude, the radius of the pylon turn will be nearly constant. The attack altitude and the true airspeed must be selected before entering the firing orbit. To compensate for the forward velocity of the aircraft, the guns are adjusted to fire slightly aft of the sight line. Now, this angle is called the gun lag angle. Obviously, as airspeed increases, the gun lag angle must be increased. Now, with your sight line directly on the target, your guns are aimed at a point might be about here. This compensates for the forward carry of the aircraft and for the ballistic drop. This simple firing geometry enables the pilot to zero in on his target throughout a prolonged attack, keeping the target under constant surveillance from 360 degrees. Of course, there's always something to complicate a basic theory: wind. Wind not only affects aircraft position and travel, it also displaces the impact point of the ordnance. Now, the pilot will maneuver the aircraft to compensate for wind drift. He will increase his angle of bank on the downwind arc of the firing orbit. He will decrease it on the upwind arc. Now, as you can see, a 30-degree angle of bank can be maintained in these areas of the firing orbit. And it's from these arcs that he will usually fire. The aim point for firing will be offset into the wind, just as you offset for wind on the rifle range. Now, if your shots consistently group off target, that indicates an error caused by wind. Of course, on board a weapon system as sophisticated as the C-130 side-firing aircraft, you have a computer that's quite capable of compensating for wind drift. Now, how do you crew members and your weapon system fit into this geometry? Let's start with the gunners. But first, I better explain that the pictures we're going to show you are not of the photographic quality of the film you're looking at right now, but the training and combat photography and the battle damage assessment footage will give you an idea of what you will actually see, how the fight really goes. So now let's get with those gunners. On the other side of the bulkhead, behind and below the pilot, is the forward gun station. These first two guns are 20mm Vulcan cannon with a rate of fire of 2,500 rounds per minute. They're manned by two forward gunners, and when these cannon are fired, you two men will be busy loading and manning. The third and fourth guns are the miniguns, 7.62mm. They have a rate of fire of 3,000 or 6,000 rounds a minute. They're used for strafing in special situations, such as support of friendly troops in contact with the enemy. They're manned as needed by one gunner from the forward or aft gun crews. In addition, one of the gunners must man the right forward scanner position. The fifth and sixth guns, the 40mm, are the truck killers. And they're as accurate as sporting rifles. The long reach of these guns gives you a greater slant range. That means greater standoff distance, which greatly reduces your vulnerability to the enemy's anti-aircraft artillery, AAA. The gunners who man the 40s will be spelled and helped by the two forward gunners. In hostile areas, that AAA has a bad habit of coming up at you. Every man in the crew who can see it watches for it. But one crew member is a specialist. He's the illuminator operator, and his position in the aircraft is unusual, to say the least. He lies prone on the open ramp in the rear and watches below for AAA. If it's coming directly at you, he calls it accurate, and the pilot takes evasive action. If the AAA angles away from you, he calls it inaccurate, and the pilot continues in the firing orbit. While he plays this tricky game, he drops ground markers. When they light up on the ground, a fighter strike can be called in against the AAA gun bunkers. If you have what it takes to be in this crew position, you'll also operate the 40 kW illuminator and the flare launcher when they're installed. The sensor operator's booth, located on the right in the center area of the cargo compartment, is acoustically treated to keep out the bang and roar of the guns. It's air-conditioned, protected by steel armor, and covered with ballistic repellent material. There are 3 officers who operate the sophisticated sensors, and a fire control officer who coordinates sensor operations. The electronic warfare officer operates several sensors. For example, Black Crow, a specialized electronic sensor, and the beacon tracking radar. Using the Black Crow sensor, he will usually be the first one to detect a truck moving along a trail. That radar is used principally to locate a friendly troop position where a transponder beacon is located on the ground. In bad weather, which is when the enemy is likely to attack, this can be of the greatest importance to ground forces. In such a situation, fire support is directed against the enemy an offset distance away from the friendlies. This officer also operates the Trim 7 and other advanced electronic countermeasure systems, the infrared reconnaissance system, the low light level television, and the 2 officers who operate them are the real night eyes of the AC-130 weapon system. The infrared sensor, the IR, is an extremely precise heat sensor. So sensitive, it can detect minute temperature differences and show it in real-time imagery, much like black and white television. Target images are magnified by a factor of 4, and the aiming reticles are etched into the display. If you're the IR operator, you will learn there are many tricks in operating this sensor, and it's your job to know them all. You can see through haze when the TV cannot. You can search the roads beneath with a wide-range picture. You can change scale for a close-up look. You can select white-hot or cold-hot polarity depending on which mode shows the target best. Jungles are cool, roads are warm, and running truck engines are hot. There are lots of questions, but you don't have to answer all of them by yourself. You're part of a team, and you can always cross-check with the TV operator. Either one of you can slave his picture to the other fellows. Television needs only moonlight or starlight to present you with a picture of the Earth below. The 2 kW illuminator is slave to the TV to brighten the image on a dark night. That illuminator, a xenon arc lamp of extreme intensity, can be operated in either a visible white light mode or in an invisible IR spectrum. It is always operated in the IR mode while in combat, so that it is not visible to the enemy below. A distinct advantage to the operator of the TV is its narrow field of view that enlarges the target by a factor of 6. Every man in the crew who is acquiring or tracking a target is measuring the aim point in terms of mils. Everybody's talking the same language, but that's still a fine sighting to make from a moving aircraft. If you're sighting and firing along a 12,000-foot slant range, 1 mil of tracking error, and you miss the target by 12 feet. For the IR and TV operators, that means stay steady. Track your target slowly and evenly, and lead a moving target by about 2 lengths for every estimated 10 miles per hour of the truck's travel. If it's a truck convoy, destroy the lead truck first. That jams up the convoy.
Yeah, see in the open or something like that?
In the open, roger.
You're cleared. Here, we got Bo with us.
Picked up by
Yes.
Okay, just sped up considerably.
he has the mover and he has got his lights on.
We're gonna need him.
He's slowed down considerably, but he's still moving. Another one up the road. TVM.
Okay,
down 300 feet.
That's all right, that's right.
Let's take the lead one, Charlie.
Roger that.
Okay.
Oh, look at that. We got dozens.
I don't know. Gun.
Going after the lead.
You can't go down 300 feet. I want a gun.
You got one.
On a stop.
125 for
Stop.
6 trucks.
Okay, but we're all right. Stop. Let's get out.
Okay.
Hit on
Kill.
hit on number 2. Hit on number.
I can't say it, boy. Breaking out.
Hey, what kind of airspeed you want that in?
Anything. Right, give me base, gunners. Sarah, one just flew up.
Roger.
Yeah, the truck that was on fire blew up.
You come up to 10605.
And we're not moving down the road before it block this up. We're moving down to truck number 5.
How do we join in for?
We cannot see the other truck.
Okay. Sorry, he just flew up again.
And that fire is big enough to blow all the trucks off the curve. In fact, the block of my truck not now.
Right, we just got 4 trucks.
Oh, beautiful.
Yeah, I think we got them all.
Oh, rest.
Uh-oh.
Get out of here. Let's break right. Get your head in. Get your head in. Get your head in. Don't. Underneath. Don't let me go there. Turn around. Keep on this.
6 o'clock, 10 more rounds. Alright.
Keep on the 6.
On as.
Keep on the 6. Hold on.
There's one other sensor switch that's particularly important. The consent switch on the operator control panel. When you depress the consent switch, you give the pilot a light signal that tells him you're on the target. The firing circuit is interrupted when the switch is redepressed and the pilot cannot fire in the automatic mode. What happens to all this target information you fellows are picking up with your sensors? It goes into the very heart of the weapon system, the fire control computer. The fire control officer determines which sensor has the best picture of the target. He computes and gives data corrections to the navigator when shots miss the target. In the AC-130A models, the analog fire control system on the flight deck displays the target information for the navigator. The navigator keeps the computer continuously updated with modifying information such as wind direction and velocity, corrections in azimuth and elevation, heading and slant range, true airspeed, coincidence, and target offset. This is the information that is passed to the pilot. It is registered continuously on his steering indicator and in his optical gun sight. Guided by this computerized information, he flies the aircraft into the attack orbit. That's when he turns into his side-mounted optical gun sight, and as he does so, he calls for armed guns. The flight engineer arms the gun that has been selected and that is on the line. In the gun sight, the pilot refines his aim by maneuvering the aircraft so that the fixed and movable reticles are superimposed. The navigator confirms that the target is clear of friendlies, and he coordinates the clearance to fire. The sensor operator is tracking the target. The consent light is on, and the pilot triggers off the shot.
Direct hit on one of the trucks.
Still float. 10 o'clock. No sweat.
No sweat.
Turn around.
Okay, direct hit on the same truck. Sparks look like it's drifting away from the water. That's for sure.
No, not
First went right in them.
Not if it has. It has drifted right
Direct hit.
Here we have a fire on the barge.
Oh, up to the middle, huh?
Started it.
Okay, that's target 4. Boat number 1.
You got balls. I can see that, Willis.
Ship. Destroyed, it's burned.
It's a ship.
Ship of the line. 16-inch guns.
Go about it now. We're on the 307 for 78 off of 94.
He's got us.
Oh, it's there. No. 5, 6, 5. Good was good. Started out 2 right.
Oh, shit. Okay, hold it down. That's going to knock out the rest of the truck. Let's get it off. They got on IR. Hold it.
We got us up tonight.
Okay. Let's knock out the top. Get the rest of the truck.
Right here. Okay, good. What do we have?
Hey, we just hit truck.
We have the biggest first I've ever seen.
Big blower. Let's get off and get the rest of the trucks. Roger that. Stay out there. They're getting shot at. Give me the next one.
Okay. We've been looking at aircraft in what we call the PAVE Pronto configuration. And there's a great deal more about this weapon system than we've been able to tell you. There's additional equipment, like the laser target designator. There's tricks of the trade you can learn only by flying the system. And there's additional equipment on board that further illustrates the degree of sophistication reached by this weapon system. These AC-130 side-firing aircraft in the PAVE Pronto configuration have really proven themselves far beyond expectations. Now, in the follow-up AC-130E program, one that we call PAVE Spectre, the weapon system is even more advanced. A new additional hydraulic system, very extensive armor plating have been installed to protect you and your equipment. An advanced digital computer provides increased flexibility to the fire control system. This enables the pilot to fire accurately even though he's not on nominal bank, altitude, or true airspeed for the selected attack orbit. If your shots miss the target, the fire control officer simply clicks in the miss distance and direction. Whatever has caused the error, wind, gun setting, sensor alignment, or aircraft skid, the computer computes the proper azimuth and elevation corrections, and that next shot should be on target. Besides the digital computer, the aircraft in the PAVE Spectre program are equipped with a heads-up display that gives the fire control officer and the pilot additional information and greater accuracy for every shot. This is a sophisticated weapon system operated by a skilled crew. The co-pilot monitors airspeed and altitude, and he makes what flight adjustments are required of him. He's also the man who's coordinating with the gunship's fighter escort. Besides his job of precision navigation, the navigator is in contact with the airborne command post, and he coordinates the clearance to fire. He plots friendly positions and keeps the battle log. Along with coordinating and selecting the tracking sensor, the fire control officer is responsible for pinpoint corrections in the fire control system, and he advises the pilot. He operates the battle damage assessment recorder and calls the results of all firing to the crew. He also records additional information for subsequent attacks and for post-mission analysis. Beyond his usual engineering chores, the flight engineer coordinates with the gunners on a private intercom, and he arms the guns selected to fire. The gunners must keep ahead of the guns, keep them constantly loaded, ready, and on the line. One gun jams, and instantly they have another on the line. Their guns are always ready for the next shot at the next target, a target the sensor operators are constantly searching for, acquiring, and tracking. And let's not forget that scanner, that illuminator operator, lying out there on the open ramp, calling and marking enemy anti-aircraft artillery. All this is going on at the same time. 14 men linked together by 3 separate intercom systems, acting together as one team. The AC-130 side-firing aircraft, developed for the Tactical Air Command, are becoming constantly more sophisticated.
105 howitzer on the line.
But the greatest thing about the AC-130 side-firing aircraft will always be the combat crews who fly them. There's no substitute for skill and guts.
Yep, big one.
TV's back.
That's a big gas truck.
TV's the anti stuff.
Go.
Rise it up, Dave. Okay, you gotta climb now.
Okay, we're going up.
Now, you still don't have secure on two.
Pilot, 2 drivers got out and are running to the rear. 3 drivers.
Well, affirmative, TV, Adam also.
They're calling you. There goes the truck again.
He's moving again.
Fire. Slow it down.
Oh, he's moving into the woods.
They're way behind me now. Level up.
No, wait a minute. They jumped it off the road. It's falling down.
Yeah,
They jumped it. The thing rolled off the cliff.
there it goes. There it goes, TV's
All right, we don't have to shoot it then. We'll just nail it in a minute.
just exploded. That's a positive.
No, no. It's gonna shoot her. You want to go up? Yeah, just keep her coming up. Okay, we can get this.
A new model troop and cargo plane was completed and put under flight testing for the U.S. Air Force in 1955. It was the C-130 Hercules, a medium-weight prop jet transport built by the Georgia Division of Lockheed Aircraft Corporation to speed men, cargo, and equipment to America's defense outposts. Construction of this aircraft was well underway when the year 1955 began. 6 production model C-130s were already under construction in January. At that time, the first plane, serial number 3001, occupied position 2 on the production line. The aircraft soon was moved to the final assembly position. A check was made to see that the actual weight of the engine, an Allison T-56, met specifications before installing it on the plane. In the meantime, Curtiss-Wright propellers were uncrated, reversible blades were fitted into the hubs, and operation of the blade change mechanism was checked. A preservative was added to the engine fuel system until actual engine runs could be accomplished on the flight lines. The engines were turned by air-ground power for the pickling process. All engines were installed by mid-February. Before the plane left the production line, installations of personnel seats and equipment were checked and found to be satisfactory. The seats were removed, and special first flight test equipment was installed. The first aircraft was then moved to the Engineering Flight Test Department for flutter and vibration tests. By late March, fueling operations and tests had been completed on all engines. High-speed taxi runs were made to check the operation of different systems and equipment preparatory to flight. The first production C-130 took off on its maiden flight on April 7, 1955. Only about 800 feet of runway were required for the takeoff. The plane was in the air 1 hour and 7 minutes. During this flight, landing gear and stall tests were satisfactory. Starting with this trip, a half-dozen C-130s logged a total of 94 hours and 17 minutes in tests during the remainder of the year. The landing on the first flight was routine. Using reversible propellers, the plane required only about 2,000 feet of runway for the landing. On a landing a few days later, however, a fire developed resulting from the failure of a fuel quick disconnect behind engine number 2 firewall. After the aircraft was repaired, more test flights were conducted. While number 3001 went through production, pre-flight, and engineering flight testing, static tests were being performed on airplane number 3002. The second aircraft had been designated as a static test article, a guinea pig for experimental purposes in the C-130 program. The fuselage of the static test article was prepared for an air pressure test. It was filled with containers to protect against serious damage should the section fail. The aft section failed at 12.74 pounds per square inch. To reduce potential damage resulting from pressure tests, Lockheed proposed that further tests be conducted hydrostatically. The Air Force concurred. A concrete pool was built for the hydrostatic or underwater tests of the aft and nose sections. The pool cost approximately $20,000, and the water method has saved an estimated $500,000. The water testing procedure was simple. The fuselage section was bulkheaded, made watertight, filled with water, and submerged. The interior was pressurized. With the conventional air pressure test method, when failure occurs, the force of the exploding compressed air causes secondary damage, which sometimes makes it difficult to find the origin of the weakness. Damage to the section is less in the hydrostatic test, since water, for all practical purposes, is not compressible. The forward section was pressurized satisfactorily. The aft section, which failed in the air pressure tests, was replaced and submerged in the pool. The section was successfully pressurized to 15.1 pounds per square inch, more than twice the normal operating pressure. Due to the uniformity of the center fuselage section, and as a result of some previous testing at the California Division, it was considered safe to test this section with air. The section was pressurized to the required 15 pounds per square inch. The outer wing flaps were subjected to extensive fatigue tests. As weaknesses were observed, designs were improved until the flaps successfully completed 8,000 cycles. When tests began on wing down bending, it was necessary to use stop-motion photography to speed up the slow bending of the wing. The jumpy movements of the workers were caused by this camera technique. The slowly bending wing withstood ultimate load for 3 minutes without failure in the test for dynamic taxi, a condition critical for the outer wing panel. It also withstood ultimate load during the test on wing down bending and main gear load, a condition critical for the wing and main gear combination. A number of other tests were performed in an effort to improve the design of the C-130. Among these were the lateral gusts on the aft fuselage, including simulated airdrop, that is, with the cargo door open. The J2 door test, the tail-down springback test, and the test on the cam followers on the flaps. When the examinations disclosed any weaknesses, improvements were made until the parts were satisfactory. Separate tests were conducted on many vital parts of the C-130. For instance, the hydraulic reservoir was filled to capacity with fluid and slashed and vibrated simultaneously for 25 hours, simulating the most severe operating conditions. There was no leakage. During the year, special tests were made on a new cargo floor design. The new floor was constructed of extruded stiffeners riveted to a metal skin, which could be used to replace the solid machine stiffened panels in event of need for wartime acceleration of the C-130 program. The rolling test consisted of a rubber tire under a load of 6,500 pounds, rolling back and forth across the floor 2,000 times. Operation of the main landing gear was observed under extreme temperature and environmental conditions and was also subjected to sand, frozen mud, and salt spray. Temperatures range from -65 to +160 degrees Fahrenheit. This tandem landing gear is designed to enable the plane to operate safely from semi-prepared landing fields. While the static test article was undergoing many rigorous qualification tests, other C-130s completed production airplanes were used for flight tests, demonstrations, and briefings for key military personnel. The first show was staged in July. Military personnel, newspaper reporters, photographers, and top television and radio people from all over the nation came to Marietta to see the new air freighter. The demonstration began with an exhibition of the flying characteristics of the Hercules. The turboprop C-130 is the fastest transport plane in production for the U.S. Air Force. It can travel at speeds of more than 370 miles per hour. A fast climbing aircraft, The C-130 can reach an altitude of 2,500 feet in only 60 seconds. A versatile plane, the C-130 can fly with the Stratojets at 40,000 feet altitude on long missions, or it can dip low enough to drop paratroops and supplies to advance military base operations. The reporters, television, and radio men watch the Hercules back up over great distances. The unique ability to travel such distances in reverse makes the plane particularly useful in combat zones where time and space are limiting factors. The steerable nose wheel and the reversible propellers allow the aircraft to park in a very limited area. The writers and military personnel saw a display of the loading capabilities of the cargo transport. Men from the 18th Air Force, Donaldson Air Base, South Carolina, staged the demonstration. A 5,000-gallon jet fuel tanker was driven into the aircraft using the built-in loading ramp which serves as a rear door. This ramp also can be put at truck floor level for straight-in loading. The plane can accommodate 20 tons of heavy equipment. The changeover from cargo to personnel transport can be accomplished in a matter of minutes. 92 troops marched into the airplane during the demonstration. The C-130 can make either aerial or ground deliveries of men and cargo. In November, the C-130 presented a demonstration of loading general cargo at Dover, Delaware for the Military Air Transport Service. A training program was inaugurated to prepare men to become crew members of this prop jet plane. Spare parts shipments to the Air Force commands, which are to receive the C-130s, were ahead of schedule. The Air Force decided to change from Curtiss-Wright propellers to Aero Products propellers. Aero props were installed on engine number 3 of the 6th airplane, and tests were begun late in the year. The cargo transport is to be used as a supply ship in the Arctic regions. Development design was started on a ski wheel for the C-130. The ski wheels were scheduled to be flight tested late in 1956. In preparation for flights into snowlands, the tail of the C-130 was painted red, the standard Arctic marking. The color makes the aircraft visible against a background of snow-covered or even desert terrain. The testing and production programs were on schedule at the end of the year. 12 C-130s had been completed. Some were released to the Air Force for testing. Airplane number 3018 was starting on production line. Climatic, aerial delivery, desert, wind tunnel, and Arctic tests were scheduled for the next year. A highlight of the year came when the Hercules made its first extended flight, flying from Marietta to Philadelphia for the National Air Show. By late 1956, the new versatile cargo transport was scheduled to take its place as an operational unit of the United States Air Force.
The mission of a tactical fighter is very exacting. More is required of these jets than any other weapon in the Air Force. We expect it to be an air superiority fighter, day or night, a dive bomber, and a low-altitude attack aircraft. We let it range over the entire tactical field. That and close air support, interdiction, and air superiority.
In the art of tactical aerial reconnaissance, there have been many dramatic developments since the Cuban Missile Crisis. Then our reconnaissance, as effective as it was pretty much limited to daytime photo and visual coverage. Today, with multi-directional sensors and cameras of unbelievable sensitivity, we can practically read the enemy's mind.
Our tactical airlift forces have been modernized and greatly expanded. We can deliver personnel, supplies, and equipment on a sustained or emergency phase as far forward in the combat zone as the tactical situation permits. Any potential aggressor contemplating an attack on any part of the free world with any kind of weapons, conventional or nuclear, must know that our response will be suitable, selective, swift, and effective.
Suitable, selective, swift, and effective. Words chosen carefully to describe the reaction of America's fighting forces to any armed threat that could, in a matter of hours, shatter world peace. Yet to those who can be called upon to deliver a nuclear device on a major target, or destroy a small guerrilla force in a dense jungle, words have special significance. They are embodied in the philosophy and in the doctrine of tactical air power. Tactical air power. It is reflected in many ways. In the packaged strike forces, capable of spanning oceans and continents in hours, prepared to fight anywhere in any climate, at any time, and at any level of conflict. Tactical air power is reflected in missiles, rockets, cannons, and bombs, and in the aircraft that carry them. Supersonic platforms from which to launch awesome weapons of destruction should this be necessary for our survival. Tactical air power can be seen in many vital support activities, and in the ground crews who perform crucial and complex tasks with dedication and competence to be certain that the weapons are always ready to go. These are the elements of tactical air power. Elements which have been produced by the Tactical Air Command. For it is TAC which develops, trains, and deploys forces around the world in support of United States Air Force operations. Wherever tactical air power is deployed in war, the first order of business is to control the skies over the combat area. Last is surface-to-air missile sites and gun emplacements on the ground. When air superiority becomes an accomplished fact, the other classic tasks of tactical air power are simplified. Interdiction, designed to prevent the enemy from supplying the necessary resources when and where he needs. On the target list, everything he requires for sustained military operations. And every means he employs to move it. Disrupting the enemy's lines of communication, destroying his supply depots, and harassing his troop movements dramatically increases the odds of success for friendly ground forces. Frequently, the immediate situation demands more direct action, demands close air support. Then, airmen join embattled ground forces in close-in fighting. The concentrated firepower of rockets, missiles, bombs, and cannon reinforces that of rifles, machine guns, mortars, and grenades to defeat the enemy. Airstrikes are directed by Air Force Forward Air Controllers, FACs as they are called. Pilots who live with Army units in the heart of the battle, or who fly above it in light unarmed patrol planes, where you are on this day in October 1965. In the dense jungle below is Play Me, Vietnam. For 6 days in fierce fighting, 2 regiments of the North Vietnamese Army have been attempting to overrun a strategic outpost manned by Montagnards and the United States Army Special Forces team. Hundreds of fighter sorties have been flown, and the strikes continue. White mats have been thrown over the barbed wire of the outer perimeter by the enemy to gain access to the garrison. The red banner marks the target location for the delivery of close air support. It is only 40 yards from our own forces. At Play Me, tactical air power broke the enemy siege and proved beyond doubt the effectiveness of air-ground teamwork in pursuit of a common purpose. This kind of cooperation is clearly evident in every role assigned to our tactical air forces. It is evident in aerial reconnaissance, which provides a vital link between air-ground operations. What exactly is the enemy's position? What is the strength of his forces? What are his movements now? And what might he be expected to do in the future? Discovering the answers is a matter of interpretation by skilled technicians on the ground and by seasoned pilots and systems operators in the air. Reconnaissance is a task for professionals who can man a variety of electronic sensors, yet use the human eye, the human mind to best advantage. Professionals who can analyze what they see in a split second, one time only pass over the target. Then, expertly relay the details to the ground or record them on tape. What is beyond human capability to detect becomes a job for the devices that man invents and perfects. Panoramic cameras that sweep enemy terrain from horizon to horizon. Oblique cameras that register construction features. Vertical cameras that isolate pinpoint targets. And radar that can look through clouds. Reconnaissance is a 24-hour surveillance activity regardless of the weather. And the information delivered to the battlefield commander becomes a weapon in his hand. Delivery is a word used frequently when describing the broad responsibilities of tactical air power. Delivery of the facts on which to act. Delivery of firepower to give ground forces the edge. Delivery of the men and tools of war directly into a combat area. This is tactical airlift, often performed on a massive scale. Airdropping is one way, and all that's required is space. In an emergency, troops arrive fully equipped and ready to fight. But at any time, tactical airlift is ready to resupply them, as well as tactical air forces, which are part of any rapid reaction assault echelon. Anything from a jeep to a howitzer can be released from an altitude as low as 1,500 feet. Loads up to 26,000 pounds can be dropped from one aircraft. Assault landing is another way to move in. Little more is required than a crudely prepared runway or a dirt strip. Tactical airlift is the long supply arm of tactical worldwide deployment. This means anywhere. And anywhere can mean areas without landing strips of any description, areas where extreme weather presents unacceptable risk. Tailored for such operations are a series of unique cargo delivery systems. The low-altitude parachute extraction system is one of them. Air Force jargon, it's LAPES. A small globe parachute, deployed behind the aircraft, pulls the lower-loaded cargo out of the rear door. 3 6,000-pound platforms per sortie can be delivered from an altitude of 6 feet, which responds to the request for supplies at the front line. Another technique, PLADS, Parachute Low-Altitude Delivery System. Parachute is dropped into the slipstream in a semi-open position. At release time, an electrical actuator fully deploys the canopy which extracts the palletized load. From 200 feet, 3,000 pounds of cargo float toward an impact area of only 60 by 40 feet. On this run over the drop zone, it's container delivery. System designed to drop 4, 8, or 12 supply canisters weighing more than 2,000 pounds each. The search to improve tactical airlift capability is a continuing process. In this offloading technique, the aircraft's engines are left running. And as one pallet rolls out, the plane moves up the line to allow room for another pallet to roll out. Offloading time for 36,000 pounds is 3 minutes. Flexibility is a characteristic of tactical airlift, just as it is of all tactical air operations. Commitments change on very short notice. They did in late April 1965. And tactical airlift crews responded to the emergency in the Dominican Republic. During a 35-day period, Tactical Air Command, Military Airlift Command, and Continental Air Command transports airlifted 19,000 passengers and over 37 million pounds of cargo, which included food and medical supplies. More than 2,000 sorties were flown, making this operation one of the most impressive humanitarian airlifts in the history of airpower. On a smaller scale, in the Republic of Chad in West Africa, tactical airlift was used in the fall of 1966 to deliver grain to a population plagued by drought. Using delivery methods developed for combat, TAC C-130 delivered grain furnished by the United States Aid Program to villages so remote that other means of transportation were not available. Swift reaction of tactical airlift for humanitarian goals supplied vital food until the next harvest would fill the granaries. Here in Vietnam, requirements for tactical airlift are fulfilled under the most adverse conditions imaginable. For this is a land where you fly with a minimum of radio aid over mountain peaks reaching 9,000 feet. Where you make a steep approach in fog or dust to avoid the rifle fire of the Viet Cong. Where primitive airstrips carved in remote jungles turn into quagmires in the monsoon rain. Yet, they come in. You call, we haul is the motto of the airlift crew. They haul the fighting men and the implements of war needed to defend the Republic. They haul the necessities of life to sustain the people. They carry the wounded to hospital and refugees to safety. A good part of the in-country airlift responsibility rests with Special Air Warfare Forces. SPAW forces, they are called. SPAW forces are specially organized and trained to meet the challenge of communist-inspired insurgencies that threaten the survival of small, free world nations. What missions they perform depends on a country's needs. leaflet and loudspeaker missions to disseminate the truth in a psychological warfare campaign, curbing a contagious disease in a remote village. Where there are requirements for civic action projects, air power plays a critical role, for in many areas susceptible to insurgency, surface transportation is all but non-existent. If assistance is to come at all, it must come by air, and it does. Everywhere, special air warfare forces and their native counterparts work side by side in the medical, technical, and educational fields to better the lives of everyone. And they encourage the people to help themselves to erase the causes of dissatisfaction on which communist subversion thrives. But the primary undertaking of SAW forces is that of training and advising the air forces in countries which have requested our help. It is a matter of strengthening defenses against a common enemy. A matter of shaping forces that can react immediately, applying the tactics best suited for a highly specialized kind of warfare. The insurgency is the communist design for the future. They have told us this. But their choice of the method of conquest does not dictate the limits or preparedness. Weapons continue to be developed and tested to answer every possible requirement for tactical air power. The F-111 multipurpose tactical fighter represents a totally new concept in a weapon system, one which incorporates a variable sweep wing. The variable sweep wing and other innovations permit the F-111 to cross oceans without refueling, to accomplish short-field landings and takeoffs, and to operate at supersonic speeds at low level or at altitude. Each new technological advance holds the promise to enhance the potential and performance of tactical air power as developed by Tactical Air Command. United States tactical air power, tested by time, recognized through achievements in moments of crisis, which reflect a pattern of events to come. What means an aggressor will use to extend his areas of domination can be anticipated, yet no one can be certain. But of this they can be. The military strength of the United States will remain as the primary deterrent. Its powerful tactical air arm prepared to strike anywhere with any amount of force required, ready to make the difference between intent and accomplishment.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.